No.
Howdy everyone! So today we are on to 6.4 acid deposition, and congratulations, your last one of unit 4. This one I'm going to go by pretty quickly. I'm going to obviously speak about the main things and any clarification in this lecture. Just know with your workbook, I would go through the kind of fine print of the lecture or the slides themselves to kind of answer that workbook. The workbook, I would say, I don't know, overall and all is probably a little bit less extreme than the ones you've had. So good job, congratulations, we're almost there. But today we're talking about acid deposition. Really, this is kind of a continuation of the last one of smog. You know how we stated how certain primary pollutants then become secondary pollutants and then can form smog. And you know, through different processes, either through sunlight or chemical reactions. You know, the same thing is the reason, the same kind of pollutants are what form acid deposition. And also now we're kind of talking a little bit more about adding water, which then causes acid rain to those mixtures. So to kind of continue it. All right, first off, when we're talking about acid rain, obviously, we're talking about a chemical property. Acid rain or acid deposition is a broad term that includes any form of precipitation with acidic components such as sulfuric or nitric acid that falls to the ground from the atmosphere in wet or dry forms. Do know that there can be wet or dry forms of it. This can include rain, snow, fog, hail, or even dust that is acidic. That's really the main idea behind this whole lecture. And as you can see kind of from this scale, we have acidic to on the left to more alkaline on the right. Know that water usually fits somewhere around about 7 or 6 is naturally occurring. 1 second, my internet just stopped, so let me fix that. Let me put you on pause 1 moment. All right, we're back. Once again, always getting kicked off the school Wi-Fi. But anyway, so just know that the natural rains or waters usually tend to be around the 6 and 7 area. But now we're kind of talking about what if we start changing that to be more acidic on this scale. Okay, so first off, acid rain has its pathways, right? There's reason why we have acid rain, where there's naturally as well as human caused elements that cause acid rain. It can happen due to natural events, but do know most of the acid rain we deal with nowadays is human caused. Acid rain results when sulfur dioxide, SO2, and nitrogen oxides, NOx, are emitted into the atmosphere and transported by wind and air currents. The SO2 and NOx react with water, oxygen, and other chemicals to form sulfuric and nitric acids. That's really the biggest kind of key point, is those two kind of mix with gases and solids or liquids, and then produce they make them more acidic. Naturally, we get acidic rain due to volcanoes and forest fires. It tends to put those elements into the atmosphere more than when they react with water or gases, then it becomes acidic. But human cause usually is really caused by burning of fossil fuels to generate electricity. 2/3 of SO2 and 1/4 of NOx in the atmosphere come from electric power generators alone. Vehicles and heavy equipment also cause it. Manufacturing, oil refineries, and industry also cause it. And you can kind of look at this nice little graphic, or maybe not nice, but really kind of shows how this system process occurs. All right, and okay, when we're talking about this one, it's key to know that acid rain has a few different formations. Referring to the conversion of sulfur dioxide and oxides of nitrogen, NOx, into the sulfates and nitrates of dry deposition, and the sulfuric and nitric acids into wet deposition. Knowledge of chemical equations is not necessarily required in this case, right? But do know that acid deposition can be either wet or dry, is what we're really getting to. We have wet deposition, which forms our acidic rain, snow, and other precipitation. Then we have dry deposition, acidic gas or dry particulates, right, or particles not mixed with water. So do know anything that is a pollutant but it is more acidic fits in this category. And the primary pollutants associated with these come from factories and automobiles, and really we're talking about SO2, sulfur dioxide, and usually what's NO or NO2 usually identified as NOx. And then really then they can form into secondary pollutants, which are primary pollutants which react with other substances in the atmosphere to create different pollutants, such as H2SO3, sulfurous acid, H2SO4, sulfuric acid as well. So and once again, any of those elements that kind of fit into the more acidic, which then can have reactions. The big ones for IB, I would definitely know SO2 and NOx. Those are usually the two main given ones that will kind of pop up on exams and tests for you all. And I think I missed a secondary one there, but like I said, know those as mainly. So here's how we have things that become more acidic, right? But you can kind of write these formulas down, or the chemical breakdown of them when they react with either water or different elements in nature, how they kind of form these either secondary pollutants as sulfur dioxide is, or which turns into sulfuric acid or carbonic acid as well, right? Or nitrogen oxide. So kind of, have I seen, are you required to know these chemical breakdowns? I haven't seen it officially on the IB exam yet, but it is a possibility. So I would write them down in your notes. All right, and this is just another example. I've added a lot of these little photos for you to kind of get this right. But once again, we have these primary pollutants that come up from the factories or vehicles. Then they have some sort of reaction either with other chemicals, gases in the atmosphere, or precipitation or water. Then they can kind of form this oxidation occurs. Then they can kind of form this secondary type of pollutant, and then we have this acidic falling onto different areas. And it's important to know the possible effects of acidic these acidic compounds on soil, water, and living organisms. The direct effect is, for example, on acid on aquatic organisms and coniferous forests. Wow. The direct effect is really what they cause to those specific things when they touch them, and we'll kind of talk about that in a moment. Then we can talk about the indirect toxic effect, for example, increased solubility of metals such as aluminum ions on fish, right? So it breaks down different elements, then those elements then go into the water sources that can have a negative impact. Then we have indirect nutrient effects, leaching of plant nutrients, making the soil more acidic, leaching out all the alkaline chemicals, which then certain plants can't need to survive, thus having issues there. And we'll talk about how to solve that issue in a moment as well. But acid deposition effects on trees. This is the direct effect, as we can say, right? But as you can see, through this, calcium is leached from needle membranes, right? It dissolves the calcium in the needle membranes, which then makes it decreased cold tolerance, increased freezing injury, right? They're just not able to handle winters anymore. For sugar maple, calcium and magnesium is leached from the soil, and then aluminum mobilized and taken up by trees due to that. So it either can cause these problems with the root systems, or its ability to act naturally in this environment. Effects on soil. Acid rain also affects the soil by the soil neutralizing the acids. Soils that contain limestone and calcium carbonate can neutralize these acids, but then you also lose that, right? Leaching, a process in which acid deposition adds hydrogen ions, which displaces important nutrients like calcium, magnesium, and potassium. So really your soil becomes acidic. And like I said, many organisms and plants can't handle, a slight change in the environment will really have these big effects on them. Leaching pushes the ions deeper in the soil so the plant's roots can't reach them, thus becoming more acidic. here's kind of a direct, nice little list of direct effects, toxic effects, and nutrient effects of what happens to each of these. Definitely, I think in your workbook kind of actually has you write this. I'm not going to go through them, but use this as kind of a guide on what the direct effects, toxic effects, and nutrient effects on all your water, soil, water, and living organisms are. Here's just a picture example of what acid rain can do to living organisms on our planet. And this is just once again, this has just a lot of nice graphics, right? But before 1880, the pH was roughly 5.6, right? But as we can see that, at about 1980 and currently, the pH levels are changing and getting more acidic, which then has these different, effects on the land and organisms. And then once again, just another kind of one to kind of show you this process as well. Look at me, how nice am I to add all these? But it really gets down to factories and cars putting this stuff up, right? And then they have some sort of reaction up in the atmosphere with gases or water and ozone, which then makes them acidic, which then falls onto plants, which then has this disastrous effect. Really, is what you need to kind of know. Now, kind of going into it, when we're thinking about these processes, so think about how acid rain forms, right? We'll use acid rain for example. Acid rain usually doesn't happen above the city that causes it, right? You may have cities like London that have a lot of factories, or Bangkok that have a lot of factories, put up a lot of these primary pollutants that then go up and then have this reaction. And of course, they're not just standing still above the city usually, right? They're getting blown away due to wind, but these processes are still happening. So usually what happens is you have other areas that are affected by this acid rain because it's downwind, or these storms move, and just they follow kind of the jet stream, right? So I find it interesting looking at this bottom right hand map. You can see probably a lot of the pollution is formed in Europe, right? We can see here the different type stuff here, but as you can see, there's a long swath of pollutant and leading to acid rain, right? That get kind of pushed off here. This is probably effect of due to going down, or with the jet stream. These particles are lifted up and then they fall in long swaths across the continent. And that's really what's happening here, right? So really what we're kind of saying is, when we're talking about acid rain, an area might get a lot of acid rain, but they might not be the cause. There might be places, around them that is causing this problem, this forming acid rain. And we can kind of really do, a few things. There are pollution management strategies for acidic deposition. It could include, right? First off, we can, have kind of a 3-step thing, or 3 R's: replace, regulate, and then restore. And these measures can reduce fossil fuel combustion. Should be considered. For example, reducing demand for electricity in private cars, switching to non-renewables, right? Kind of along the same lines of what we talked about in the last kind of lectures, as well as what we talked about in global warming. But how do we replace? Well, we can switch to renewable energy sources, reduce fossil fuel use, right? Kind of solve the problem where it starts. Increase energy efficiency, right? Better light use, better appliances, more public transportation, meaning less automobiles. Use low sulfur fuels, right? That would replace or kind of solve the problem. When we're regulating, install, if we can't do some of those things, regulate, right? Install scrubbers on smokestacks of coal-fired power plants to remove SO2. We could install catalytic converters installed on automobiles, which many countries now have, that stop these pollutants from leaving your car. And then restore, if the problem has already occurred. Here's what we can do. We can add lime to acidified lakes and streams, as well as add lime to soil. Forestry plantations to kind of get rid of some of the acidicness of it. And then, what is that last one? UN Convention on Long Range Transboundary Air Pollutants. 1970, sorry, I can't see it. My computer won't allow me to. Okay. Subsequently amended and modified by US, Canada, and Europe. So just kind of coming up with legislation to kind of have these cleanup acts to kind of revitalize these areas that have been affected by acid rain or acid soil. And kind of going into this, right? But kind of how do we solve or clean up and restore areas that have been damaged by this? Because it's not easy, right? Once an area becomes acidic, it's not easy to kind of balance itself out. It takes a long time. So what we can use is the use of limestone or lime. A process called liming is a practice that people can do to repair the damage caused by acid rain to lakes, rivers, and brooks. You can also add it directly to the soil. Adding lime into acidic surfaces, water balances out the acidity. It's a process that has extensively been used, for instance, in Sweden, to keep the water pH at optimum. Even though liming is an expensive method and has to be done repeatedly, furthermore, it only offers a short-term solution at the expense of solving the broader challenges to SO2, NOx emissions, and risks to human life, right? So really what we're getting at here, ladies and gentlemen, is, I kind of, when writing this, is kind of like, it's a process what we need to do to restore areas that are already affected by it, but we need to actually solve the underlying issues of causing, otherwise we're just going to have to continually keep doing this in the long run. That's the last slide. Whoa, see, I told you that was quick. I kept it about 17 minutes. Guys, once again, this one is not too difficult. There's not too much into it. And it really kind of, once again, we go over many of the things that we have already talked about. The why we have these type of things in the atmosphere, why there's atmospheric pollution, then how primary pollutants then become secondary pollutants, and then there's these bad things that happen, and then we kind of talk about how we can solve these issues. So do know them. But once again, I think this is just kind of an addition to what we've already discussed, but just know acidic rain as well as other particulates is just a kind of a subgroup of what we've already been talking about. All right, guys, that is it. Please have a great day. Get ready for your exam. Have a good one. See you later.